Hi, I'm Andrew Armstrong. Welcome to the back office Teardown Lab. Today we've got a central heating controller, and that's because this central heating controller has a fault, and this was one in my house. I've since replaced it with a much simpler unit as it was only actually controlling the hot water. So we're going to take it apart. It has this quite nifty back plate on it. These are reasonably good, but this is the second time I've had one of these blow out in this particular way, and I'm beginning to think there's a little bit of a fault with the design, and it's not necessarily with the same central heating circuit, and I'll show you why. Just pop out these screws. You can see I actually have been in this already, and that's because I needed to diagnose a fault, but that's fine. Hopefully it'll be a new experience for you, even if it's not one for me. So this is the Horst Mann Centaur Plus C27, and actually they're not bad. They have quite good controls. You can retrofit them into most systems, and they do pretty good programmable thermostats and things like that. And they're pretty much in the budget end of the market. So you'll find one of these for about £30. Inside you'll find the standard sort of screen. It's a bit weird actually because there's two. There's one on the outside here, and then one on the inside. So I don't know if that's a polarizing filter. Doesn't look like it is though, does it? Strangely enough. Then the screen itself, and that's held on with the typical pink membrane down the edge. Don't know if it's me, but the screen appears to have gone a bit dark. Here we go. How about a bit more light on the subject? There we go. So you can see here, that's the screen and its membrane. We could pull it apart, there's nothing stopping us, but I want to show you the fault first. So all of the bits have dropped off as I've turned this around, but I'll just push these pins out. It's got a nice system, you see, so you can actually fit the bracket to the wall, all the electrical connections, and it just plops on the top to be serviceable. Inside you've got the contacts here for the battery backup. That's just a standard lithium cell, drops in there normally. You've got a couple of relays, one for the central heating circuit, one for the hot water circuit. Big capacitor. Your micro that's doing the whole shebang here, and let's have a look, see if we can see exactly what it is. Looks to me to be an NEC SGP 78931 if you want to play at home. Let me know what you think this is. SW6, that's switches or a serial port, who knows. We could probably actually work it out from the pin out if we really tried. So you can see that's the chip here, guys. There's the label, so if we assume this might be pin 1 here, which might be being assumed wrong, but let's say that is. All these port pins coming out here, you can probably tell me what's going on. It looks like here there are some, these are sort of solder jumpers, and some of them have links in them and some of them don't, so they've certainly got dual purpose here. J1, this is another jumper block, so it's a bit mysterious here. P5, they've got a jumper here on a P5, yeah, you'd expect maybe on a J line. Okay. Enough with that. Let's go straight to the fault. I want to show you that, pop the screen off. Something bad happened here. Now, the actual fault was exhibiting itself as a blown flipped RCD unit, and it was actually quite hard to track down what was happening because despite all of this explodiness, some of the central heating was clearly still working. And on further investigation, you know, I could actually smell there was some burning going on, and figured out this unit clearly had an overcurrent issue. And looking at the pinouts here, okay, so you've got on this board here, you can't quite see it up because of the light, but neutral, live, 1, 2, 3, 4. So neutral and live. So this is the live line. It's going to these relays here, and then being fed through to the other circuits, you know, for the actual central heating, power the central heating circuits, probably for your two-way valve or three-way valves and things like that. So what's happened is, clearly there's been an overcurrent issue, and the tracking here has taken the brunt of that. So if you have a short circuit somewhere up the line, this PCB is going to get it, and there's no fuses or anything like that on here to save it. So what would have been nice actually if they just put a fuse in here, because depending on how your central heating is set up, this guy could be one to go, because you tend to not have separate circuits for all of these things. So, you know, technically you could put a separate circuit with separate fuses for all your valve gear and your pump and all of those, but they tend not to be. They tend to be just driven from one single point, and that single point can have a big old fuse in it, unfortunately. I'm not sure what the current rating should be. Maybe it could be 5 amps, certainly probably not 13, but 5 seems maybe a little bit low, but more than enough to fry PCB when there's a fault condition. So as I said before, this is one of the second, I think, time this has happened. It took me a bit more time to actually figure out exactly what was going on, because it was sort of temperamental. So I'd sort of started buzzing this out and manually hooking up. It wasn't happening all the time, so it was really getting confusing. And then eventually I found it out, because there was another bang, a bit of a spark when I was fiddling around. And that was here. This is the actual synchro motor in one of the two-way valves, one of the zones in the house. And this was easy enough to replace. You know, replacements for these are really cheap and really easy to fit. So, you know, you don't really have to worry about that side. That's actually not a problem. But this is weird. It looks like there's been a failure within the windings of this coil in here. If I look at this with my meter, you know, I'm not sure what we're going to try to see here. In fact, I haven't even tested this to see what's going on. You know, what would be the expected resistance of a synchro? Again, if you're playing at home, you let me know. I've got no idea. But clearly whatever was going on was happening occasionally, and it happened good and proper. Took out this PCB and kept popping the thing. So both replaced, both working great. A little bit disappointed about this. I'm not going to be able to crack this open, because frankly these are going to be so difficult, but it really stinks. So I suspect the windings are dead. So if you've got any central heating woes, be interesting to hear them in your comments and how you solve those. Please feel free to click subscribe, and if you click subscribe, you can actually click somewhere on there. It will actually notify you when the videos are uploaded for more teardown fun. As ever, thank you for watching.